Hello everyone and welcome back to the channel. Today, we're diving deep into a topic that's not just reshaping technology, but our very future: the evolution of artificial intelligence. For years, AI has been this incredible force, learning from vast amounts of data. We've seen it master games, generate stunning art, and even help scientists make groundbreaking discoveries. But what if I told you the way AI learns is undergoing a fundamental shift, moving closer to how you and I understand the world? Think about it. As humans, we don't need to see millions of pictures of cats to know what a cat is. We build an internal model of the world based on our experiences. We understand that if we drop a ball, it will fall. We can predict what a cat will look like from a different angle, even if we've never seen it from that specific perspective. This predictive, common sense understanding is something that has been incredibly difficult for machines to replicate. Until now. This is where the story gets really exciting. For a long time, the dominant approach in AI, especially in what's called self-supervised learning, has been something called generative methods. Imagine an AI looking at a photo with a piece missing. A generative model tries to fill in that missing piece pixel by pixel. It has to create or generate the exact details. This is incredibly powerful, but also computationally expensive, and can lead the AI to focus on irrelevant details. It's like trying to understand a story by memorizing every single word, instead of grasping the overall plot and characters. Another approach is called contrastive learning. This method learns by comparison. It's shown two things and has to figure out if they are similar or different. For example, it might learn that two different cropped images of the same dog are related, while a picture of a dog and a picture of a car are not. This is more efficient than generating every pixel, but it still has its limitations and relies heavily on carefully chosen data augmentations. Now, a new paradigm is emerging, championed by AI visionaries like Yann LeCun. It's called JEPA, which stands for Joint Embedding Predictive Architecture, and honestly, it's a game changer. JEPA doesn't try to fill in missing pixels. It doesn't just compare two images. Instead, it operates on a more abstract level, much like our brains do. So, what is the science behind JEPA's framework? Let's break it down. The core idea is to predict representations of the world in an abstract space. Imagine you have an image, let's call it context A. You take a small part of that image, let's call it target B. Instead of trying to reconstruct the pixels of B from A, JEPA takes A, converts it into an abstract representation, a set of numbers that capture its essential meaning. Then, it tries to predict the abstract representation of B from the representation of A. It's a subtle but profound difference. The model is no longer bogged down with predicting every single blade of grass or every strand of hair. It's predicting the essence, the high-level concept. It's learning the underlying structure of the world. For example, given a video of a car moving behind a tree, a JEPA model wouldn't try to repaint the car pixel by pixel as it reappears. Instead, it would predict the abstract concept of car re-emerging on the other side. This is so much closer to how we reason about the world. We don't mentally repaint the car. We just know it's still there and will come out the other side. This approach has several incredible advantages. First, it's far more efficient. By focusing on abstract representations, the model learns the important features of the data without getting lost in the noise. This means it can learn more robust and useful models with less data and less computational power. It's about learning smarter, not just harder. This efficiency is crucial as we try to build more complex and capable AI systems. Second, it leads to better, more generalized world models. Because JEPA isn't tied to the specific details of the training data, it can develop a more flexible and adaptable understanding. This is the holy grail of AI research, creating systems that have a degree of common sense, an intuitive grasp of how the physical world works. A JEPA-trained model is better at tasks like object recognition and segmentation, especially in new and unseen situations, because it has learned the fundamental relationships between objects and their context. So, we've talked about the theory, but how is this actually being used? Let's move from theory to practice and look at the real-world scenarios where JEPA is making a difference. One of the first and most impressive implementations is iJEPA, the image-based joint embedding predictive architecture. This model was trained on the massive ImageNet dataset without using any traditional labels or augmentations. The results were astounding. It set new state-of-the-art performance on a variety of computer vision tasks. It demonstrated that by simply predicting abstract representations of image patches, it could learn powerful semantic features. For example, when researchers analyzed what the JEPA model learned, they found that it could identify objects and their parts with incredible accuracy. It understood that a bird has wings and a beak, not because it was explicitly told, but because it learned these relationships by observing the world through images. This is a huge step towards machines that can see and understand the world more like we do. But it doesn't stop with still images. The real world is dynamic, constantly in motion. That's where VJEPA, the Video Joint Embedding Predictive Architecture, comes in. Video is the ultimate source of information about the world. It shows us how objects interact, the laws of physics in action, and the flow of events over time. VJEPA is designed to learn from this rich source of data. By watching unlabeled videos, VJEPA learns a model of the world. It can predict what's going to happen next in a short clip, not by generating the future frames, but by predicting the abstract representation of those future frames. This has massive implications. Imagine autonomous vehicles that can better anticipate the actions of pedestrians and other cars, or robotic assistants that can understand and interact with their environment in a more natural and intuitive way. VJEPA has shown remarkable performance in tasks like action recognition and temporal localization. It can understand what is happening in a video and when it is happening, all from learning in a self-supervised manner. This is crucial for applications ranging from content moderation on social media platforms to intelligent surveillance systems that can identify unusual events without constant human oversight. The potential applications are truly mind-boggling. In medicine, JEPA-based models could analyze medical scans to predict disease progression with greater accuracy. In climate science, they could learn complex models of weather patterns from satellite data to improve forecasting. In robotics, they could enable robots to learn new tasks simply by watching a human perform them. What's so powerful about this entire approach is its scalability and generality. The core principle of predicting in abstract space can be applied to almost any type of data, not just images and videos. We could see JEPA-like models for audio, for text, for complex scientific data. It represents a unified framework for building intelligent systems that can learn about their environment in a self-supervised, efficient, and robust way. We are at a pivotal moment in the history of artificial intelligence. We are moving away from brute force methods that rely on massive datasets and computational power, and towards more elegant, brain-inspired architectures. JEPA is at the forefront of this revolution. It's not just another incremental improvement, it's a fundamental shift in how we think about machine learning. It's a step towards creating AI with a deeper, more grounded understanding of the world. An AI that doesn't just recognize patterns, but actually predicts and reasons about the world in a way that feels a lot more like us. The journey is far from over, of course. There are still many challenges to overcome, but the path laid out by JEPA is incredibly promising. It is a path that could lead to truly intelligent machines that can assist humanity in solving some of our most pressing challenges. It's a future where AI is not just a tool, but a true partner in discovery and innovation. Thank you so much for joining me on this deep dive into the future of AI. It's a complex topic, but I hope this breakdown made it a little clearer. What are your thoughts on JEPA? Where do you see this technology having the biggest impact? Let me know in the comments below. And if you enjoyed this video and want to stay updated on the latest breakthroughs in science and technology, make sure to hit that subscribe button and turn on notifications. Thanks for watching, and I'll see you in the next one.